Okay. So as said, this SNMP is your application layer protocol, like your HTTP or DNS or FTP or TFTP kind of application protocols. So that provides a message format for the communication between your SNMP manager and the agents. SNMP manager and agents. So this a specifically designed protocol for your network purpose. It just carry the messages between your SNMP manager, or we also call it as your network administrator also, to collect the information from these agents, different agents. So here you will this SNMP protocol, which provides this service, it can gather the information from the network devices, like if, maybe from your workstations, servers, or network devices such as your SNMP router, SNMP switches, SNMP appliances. Okay. So appliances means it provides some additional securities, like your web security appliances, or your what you call the access control list appliances, or intrusion detection system, or intrusion prevention system, that is specially designed devices. So this SNMP system consists of actually two elements. One is your SNMP manager, and another one is SNMP agent. So this SNMP manager runs the SNMP manager software here. You runs a software. There are different software tools are there. So those software, the SNMP software run by this manager, and the SNMP agents, which are the nodes being monitored by this manager, means different agents, SNMP agent for your router, SNMP agent of your switch, SNMP router of your other appliances. So they will these nodes are being monitored. Why these nodes means these nodes basically used for different application purpose. So how the communication takes place between your SNMP manager and the agents, they are the part of your network. So this SNMP allows the network administrator to follow the or manage these devices by sending the SNMP messages. How? So the SNMP, as we saw in when we talked about this network infrastructure, we have a system SNMP manager. This SNMP manager is going to control or configure this router by sending certain messages by giving the command that get command. So we have seen that when this SNMP manager connected to this router, when the software is run by your SNMP manager, there we have seen what are the different routers are there. In the example, in the video, we have seen that we try to change the edge router 1 name to your edge router 2, if you recall that video. Okay. So that way, by sending this get command, you're going to do the configuration on these agents. And whatever the IP addresses which are collected by these agents, if those IP addresses are in the form of suppose bits, by sending this get command, you may change from bits to your octal format, or you may change into a string format, you may change into means collecting the information. Okay. So basically, by sending this SNMP communication messages to the agents and collecting the information from the agents, the management information base we call the MIB. The management information base is a database that is on the agent that store the data and operational statistics about this device. So when the manager runs the SNMP software, So this SNMP software tries to get this MIB, the management information base, as a reply to this manager. So in MIBC, the entire information of this agent will be there in this database. So to configure this SNMP on these networking devices, it is first necessary to identify the relationship between this manager and the agent first. So SNMP manager is the part of your management, which kind network management system, we say, in the network side. That means it is this all these devices will be completely managed by the network administrator. So this SNMP manager runs the SNMP management software, as we said. So how it is going to be correct means the SNMP manager can collect the information from these agents by setting this get and this get action, and can change the configuration on these agents by giving the command set command. So in addition, this SNMP agents, whatever the request comes from this SNMP manager to these agents can forward the information directly to this manager by using the command trap command. So this is the basic functionality of your SNMP. And another network security protocol we call the first one is your access control, as we said. Second one is your SNMP. Third one is your network flow. So if you see this small network, there are two PCs are there, PC1 and PC2. Now PC1 connects to PC2 using a service called HTTPS service. Is this HTTPS service belongs to which layer of your network, TCP IP suite? Yeah, the application. Now sometimes PC1 may connect to PC2 using the only HTTP only. It may be connect by using, suppose if there is a remote connection, it may use the SSH or remote connection purpose. So for all these services, their port numbers are also different, right? Different port numbers are there. And how these PC1 and PC2 are identified means they identify with their IP addresses. Suppose 192.168.1.15. This one is, let us assume that 172. Suppose 16. So 15. Suppose 50. So in each packet, you will have these source IP addresses, destination IP addresses, source port number, destination port numbers. So with the help of port number, your devices, network devices or end devices can identify which service it is. If it is suppose 8080, suppose port number, or the port number 80, that means it is HTTP. If it is suppose 443, suppose, or I think 453, that means it is your HTTPS. If it is 21 port number means that represents another service. 21 means your SSH one. So based on that, they can identify. So in this NetFlow is the technology that provides the statistics on the packet, which is flowing through any of the router in the network, the packet flow. So while the SNMP attempts to provide a very wide range of your network management features and the options, but here NetFlow is focused on the providing the statistics on your IP packets only, whereas your SNMP provides the information of all other packets. Like means what is the time session established between your source and destination. That means it maintains the information of your not only application layer protocols, It also maintains the information of your transport layer protocol, that is, which service is using TCP or UDP. In application layer, whether they are using the HTTP or HTTPS or FTP or DNS. Also, the SNMP maintains the session time also. If it is a TCP connection establishment, suppose, then at what time the session started, the traffic going inside the network and outside the network. Okay. Whereas it belongs to your layer 3 protocol, suppose layer 2 protocol. That means it also maintains which routing protocols are used to transfer the packets for traffic, whether it's static routing protocols or dynamic routing protocols. And at the layer 1, which the bit streaming is used. That means whether the character stuffing or your bit stuffing is used to generate the frames. So that will be maintained. But whereas your NetFlow only works on your packet flowing through the router or the multi-layer switch. Okay. So in that packet flow, what it is going to be interested in, the NetFlow means NetFlow is just provides the data to enable the network and security monitoring is one. It enables the network and security monitoring. Means what? It is network monitoring and your security monitoring. So what do you mean by network monitoring? Yeah, traffic. Network monitoring is one is traffic, another one is what are the routing tables are used, what are the whether the links are enabled or visible. If link failure is there, then the packets cannot be transferred through that link, right? Through that channel. And at the same time, the security monitoring, that means it also checks whether the packets which are coming inside the network and going outside the network, whether they are originated from the legitimate user or malicious users. So that will check by following your AAA, authentication, authorization. That is additional service. We will talk about that. And then this NetFlow also gives the network planning. So network planning means what? How it will help for the network planning. So as we said, we discussed, whether it is a small network, medium size network, or large size network, right? If it is a small network, suppose limited number of users are there, then the traffic will be balanced. But if it is a medium size network, that means your medium size network, we say networks of network, right? That means it connects LAN 1. Let me say LAN 1 is connected, suppose LAN 2 is there, LAN 3 is there. If all these are connected through a router, then if the flow between your LAN 1 and LAN 2 is more traffic flow compared to a traffic flow from your L1 to your L3 or L1 to L4, in that case, try to divide this LAN into some other LAN, that LAN 1 separate the traffic, that LAN 1 and your LAN 2. So how it is going to take the action by the NetFlow means, when it is monitoring the packets, it finds that from which user the packets are generating more, the traffic is generating more, and to which user the traffic is sending or intended. Okay. In that case, if those ports are suppose separated at the router, okay, so then the traffic will be taken place between only L11 and L22, not from your L1 virtual LAN to your L2 virtual LAN. So based on your traffic flow, you can plan your network so that your network bandwidth will be balanced to send the packets without loss from source to the destination is another one. And you will have the traffic analysis to include the identification of your network bottlenecks. And at the same time, it will provide the IP accounting for billing purpose. IP accounting for billing purpose. Can anyone give any idea about this? IP accounting for billing purpose? For example, when you are moving from your local network to a remote network, suppose, by considering your mobile phones only, when you are going to other countries, it will allow you that how much MB of data that you can use per day, or how much GB of data that you can use per day. If it is going beyond the given, suppose 1 GB per day with no cost, if you are using the network data more than 1 GB, then your service provider will charge you, right? So using this NetFlow, they find that what is the bound is there. I mean the limitation is there that will be set. Beyond 1 GB, if any data is flowing from your device to other network, then for that data, you will be charged. So that is your IP accounting for billing purpose. So based on your IP address, okay, it identifies from where the data is originating and going. So based on that, the billing will be there. So this is possible with your NetFlow. So these are the basic services which are important. First and foremost is your network and security monitoring is one. Second, based on your traffic flow, you can plan your network. That means you can you can establish more number of virtual LANs to balance the network inside the network management system. And the traffic analysis, including the identification, that means what type of traffic it is there. Is it HTTPS traffic? Is it FTP traffic? Is it the DNS traffic? Is it the any other audio streaming traffic or video streaming traffic? And the IP accountability, as we discussed. So this one is suppose in this case, if you are seeing this, the PC1 connects to your PC2 using the applications such as your HTTPS. So that gives the traffic analysis identification. So how it works here then? So in this connection, we are finding there is the NetFlow will be enabled at the edge router, and to analyze this NetFlow or the traffic flow from PC1 to your PC2, there will be a specialized device will be configured inside the network. We call that NetFlow collector and analyzer software. So this NetFlow can monitor that application connection and tracking byte and packet count for the individual application flow. So it then pushes the statistics over to the external server. We call this the analyzer. So this NetFlow technology has seen the several generations basically, but the NetFlow it should one of the 5 fields that this the network analyzer will check. So what are those means? Based on the different flows, it will the packet could safely determine to be from the different flow based on, as we said, if you have the extended ACL, there it is following the different field of your packet, right? One is your source IP address, and another one is your destination IP address, so the source IP address and your destination IP address. Along with that, what will be there? Which service is which service traffic is going on from your source to destination means to identify this service, we use the port number, right? So you will have the source port number and destination port number. Source port number and your destination port number. Apart from these four, you will have other, the information also, the fields in that packet. One is your layer 3 protocol type. Your layer 3 protocol. So in the layer 3 protocol, what you will find there? In the TCP IP suite, in TCP IP suite, what layer 3 protocol type that you will find? If it is OSI model, then it is your layer 4. If it is TCP IP model, it is a layer 3. So what is the layer 3 in TCP IP model? Yeah, TCP and UDP. So it provides the layer 3 protocol, which service they are using, whether TCP or UDP. And along with that, the type of service marking will be there, and the input logical interfaces will be there. So we'll see this, the basic part of your NetFlow. So then comes to another service, the fourth service we call the port mirroring, or we call the packet snipper also. So here in this architecture, if you see, for your PC1 suppose, and PC2, PC3, when they are connected in this, the infrastructure. Now tell me, from this infrastructure, is it a private network or public network? It's a private network. It is using one switch and all the end devices connected to the switch. It is not connected to the public network. To connect public network, switch must connect to your router, and then from router it connects to your public network. Okay. So in port mirroring, in this case, the packet analyzer, also known as the packet snippers, we call the traffic snipper or your packet the sniffer, is typically the software that capture packets entering and exiting the network interface card, the NIC card, which will be there at every port of your the switch, or the NIC card will be there here. There will be one NIC card here. Here is one NIC card. So every device is having the network interface card. So this packet sniffering it is not always possible or desirable to have the packet analyzer on the device that is being monitored by the switch. So sometimes it is better on a separate station to maintain the packet analyzing, whatever the captured packets are there by your switch, that will be one copy of that traffic is given to your packet analyzer, so that this packet mirroring, the port mirroring will not affect, or packet analyzer will not affect the traffic flow from your PC1 to PC2 or PC1 to PC3. It will, naturally the flow will take place from one workstation to your another workstation in the network. In the background, the packet analyzer is going to analyze the which packets are coming inside the network, which packets are going. That is based on, again, the port numbers only. So because the network switches can isolate this traffic, so traffic snipper or other network monitors such as your intrusion detection systems or intrusion prevention systems, they cannot access all the traffic on the network management, the network segment side. In this segment, So the port mirroring is the feature that allows a switch to make as the duplicate packet, and that will goes and give it to that is separated and analyzed by this packet analyzer here. So the original traffic is forwarded in as usual manner, as we said. So what is going to be analyzed by this packet analyzer here? So this packet analyzer again analyze what is the source IP address, source and your destination IP addresses. That means the source IP address is, if it is sending in this case, source IP address is this and this one is the destination, and which service it is using. Suppose HTTPS, the HTTP is there, that means it uses the port number 80. If it is SH1, it may use the port number 21 or 22 for telnet, and different services, different port numbers are given. So that will be analyzed. That means what? Whether these IP addresses are legitimate IP addresses or not, that will be analyzed by this analyzer. And they will check what is the traffic is going on between the source and the destination. That is based on the port number. Right? So this is the another one, and basically there is an advantage with this port mirroring as well as disadvantage is also there. If any of these users in this network, if they become the attacker, suppose, if they try to access only this packet analyzer, then they will get the entire network information. How many end users are there in that network? What are their IP addresses? Which, what is their activities, like whether they are frequently accessing web pages or frequently accessing the FTP service or frequently accessing some domains. So entire activity will be captured. So in that case, suppose if you are using frequently accessing your bank transaction, suppose through web page, HTTPS service, then they try to analyze that at what time your regular interval. Suppose after a period of time, if you are analyzing, you will find that what is the activity. This user every Saturday or every Sunday, this user at 10 o'clock is trying to access bank portal. Or suppose in between 9 o'clock to suppose 12 o'clock, he is trying to access the bank portal. So during that time, your attacker will be active and look into your traffic, whether now he started sending any packets or not. And by analyzing that, he come to know that, okay, a corner is going to access the portal in between your 9 to 12. That time he will be very active. Suppose he is trying to attempt to access the bank portal. In the first request, your packet will be captured by attacker, and that packet will be analyzed by like Wireshark or some other the attacking tools that we are going to discuss. By using those tools, he will get your credentials, the attacker. What is your username, your password, and so by using that, he will bypass your traffic to the bank. Your traffic will go to him. He is going to activate. He or she will, trying to access bank on behalf of you. So bankers think that if the traffic is coming from legitimate user only, from corner only, but actually going from Rashtra. So that's the way of by this port mirroring or stripping. There is one danger. Yeah. So another the security service is your Syslog servers, which are basically used to maintain the logging information, as we said. Okay. So this Syslog servers, they use this Syslog protocol to communicate with each other. The network devices, they can communicate with the Syslog server by using the Syslog protocol. So when certain event occurs on a network, suppose, so networking devices have trusted mechanism to notify the administrator with the detailed system messages. So these messages, what are the detailed system messages that it will give? It will find this system protocol. In that system messages, you will find at what time the user is logged in, as we just explained. At what time the user is logged out. At what time the user trying to access which resource of your network. That means whether your user is accessing the server, I mean the core server or payroll server or health server. So which resources that the user is accessing. So for analyzing purpose, the Syslog protocol is used, and these messages can be either the non-critical or the significant. But network administrator have a variety of options for storing, interpreting, and displaying these messages, and for being alerted to those messages that could have the greatest impact on the network infrastructure in this case. So the most common method of accessing system messages is to use a protocol called the Syslog protocol for sending the request as well as getting the information from these network devices. So many network devices support this Syslog, including the routers, switches, application servers, your firewalls, and your network appliances. So the Syslog protocols allows the networking devices to send their system messages across the network to Syslog server. But the Syslogging service that provides three basic the functionalities or the primary functions we say. One is the ability to gather the logging information for monitoring the troubleshooting purpose. And second one is the ability to gathering the logging information that is captured. And third one is ability to specify the destination of your captured Syslog messages by getting these Syslog messages for analyzing purpose. So this is again the another administrative duty which use this network security services to analyze. So this is another important service. Okay. And the next service is your NTP, we call the time configuration protocol, the network time configuration protocol. So in this NTP, it is important to synchronize the devices which are connected inside the network. So synchronizing the devices means what? Whatever the traffic is analyzed here, suppose by this workstation, that information must be shared with all other network devices. I mean the network administrative devices inside. So there should be updated information at each level. So because it is very important to all the devices on the network, all aspects of like managing, securing, troubleshooting, planning the network, that requires the accurate and consistent timestamping. So when timestamp is not synchronized between devices, it will impossible to determine the order of the events that have occurred in a different part of your network. So as we said, by following the NetFlow, suppose at this part, the NetFlow, if this device is not synchronized with any other devices, then other devices don't know that traffic is going on from which LAN to which LAN, the heavy traffic, and the average traffic is going on from which virtual LAN to which virtual LAN. So if that is not known, then other devices they cannot they are unable to plan the network. So that information sharing is required. For that, all the devices must be synchronized. So for that, they use the protocol your the NTP. You configure the network time protocol, or it may be done by manually on manual configuration of your date and time. Okay? These are two ways. So in this NTP, the network time protocol, it is structured as the hierarchy. Structured hierarchy is used, so that we call it as your the stratum 0, stratum 1 level, stratum 2 level, stratum 3 level, and so and so. So as network grows, it becomes difficult to ensure that all infrastructure devices are operating with the synchronized time, because as network grows, your what you call the network infrastructure devices like switches, routers, or the security appliances like your web security appliance, or your email security appliances, or your configuration at on edge router, suppose ACL service or other services like NetFlow services. So it is difficult to compromise. So if this protocol runs on all these devices, then any changes happens at any level. It may be your access level or distributed level or the core level in the network hierarchy, that this NTP will be automatically update the system in terms of date and the time. So the better solution it gives in the updating the time and date at every level. So NTPs, they arranged in these three levels, which are known as your the strata. So at 0 level, NTP that gets the time from the authoritative time sources, the first level, and they are directly connected to your the stratum 1. They will synchronize this, and these devices further try to synchronize with your stratum 2 devices, and so on. So this, because of this, how it will helpful for your network to providing this security. Today, one of my student has given a presentation. There, we had one topic, that patch management. Whether you need to update the patch immediately, or it requires some time. So there, if this NTP detects that your system is out of date, your system software is outdated, try to update it with the bugs or patches or something. How it will be identified to the user? By running this network and protocol. It says that your system is outdated up to this date, try to update it with the new patch or something like that. It will alert you. If you are unable to update that patch in that given duration time, then it will lead to a vulnerability of your system. So attackers trying to check, always trying to find the vulnerability of your system. If it is there, means it is easy for them to get into your system, get into your network. So that is the most important one. That's why this network security, all the devices in the network must be updated, synchronized. Okay. Yeah. So that is the important of your NTP. One. So next comes to the very important the security service we call the AAA. AAA. That is your authentication, authorization, and accounting. These three. So, yeah, the AA servers for giving the security to your network. That is the authentication, authorization, and accounting. Authentication means what? when you are trying to access the network, it is the network administrator responsibility to allow only authenticated users to get into the network. So how? By giving the credentials to the user, we call the authentication. So that credential, it may be like in terms of username, password type, by entering username and password, or it may be like challenge and response time. Challenge and response means there would be a question. If you answer that, then you will be allowed to get into that. So what are those questions and answers means? Only the closed group, authenticated users only knows those questions and their answers. That is challenging response. Or other one is the token system. So token system means your network administrator give you one token for a period of time. Or say that single time using, like one time password. So only once you may enter into the network. Second time again you want to enter into the network means you need to get another token. So these are different methods are used for your authentication purpose. So this authentication is just to identify whether you are a legitimate user or not. Right? So that different services are used, as we said, the username and password, the combination, or they may use the challenge response questions, token cards, or any other methods like sending a OTP, one-time password, in terms of text to the mail. So that is your authentication. Now, once you are authenticated to get into the network, okay, now the authorization is required. So in this authorization, the privileges will be given to you. Suppose for students, some privileges will be given. For faculty, some privileges will be given. For the administrative staff, some privilegation will be given. Okay, that means as a student, when you are getting into our the canvas, you are able to access your registered courses, right? And you are able to check your activities of that course. You cannot create a course. You cannot create any the videos on that. You are just able to access the content which is provided by the faculty, correct? And when faculty enabled you a service that you can start writing the exam, those kind of services. So privileges are limited. Authorization, what resources that a user can access. As a faculty, for me, it is given that I may create the course, I may update the course content, I may allow you to create my student users in that course, their assignments, grading, are all different privileges. Okay? So that is authorization. Which set of services given to individual user or a group of users? So that is authorization. And second one is accounting. The third one is accounting. And this accounting means, again, as we discussed, it may be your IP-based accounting, or it may be your TCP or UDP service-based accounting. Okay, UDP service-based accounting means at what time you logged into the network, which service you are using. Suppose if you are using UDP service, that means you may stream the videos, or you may stream audio, or combination of video and audio. Correct? So that traffic can be analyzed. So in bigger organizations, as we said, in corporate sector side, the corporates, they don't allow their employees to work streaming any video, suppose. Then they will just disable the UDP service. Only use the TCP service, so that the supported, because UDP supports for streaming, whereas TCP partially supports it. So accountability will be there. For example, the student access the host server by using the SSH service, by using this port number for 15 minutes. So these three are most important: one for authentication, authorization, and accounting. This is another network service, and which is most important one. Okay. So let me just summarize that. We have seen in this network services, first and foremost important one is your access control list. So then you are having the simple network management protocol SNMP. Then we have seen the NetFlow. The NetFlow, and then we check the AAA one, which is most important one: authentication, authorization, and accessibility. And for synchronizing all the devices in terms of date and time, it is NTP, network timing protocol for synchronization purpose. And to maintain the log information, we use the Syslog protocol for maintaining the Syslogs, right? So these are, and for analyzing whether the packets are coming from the legitimate users or not, for that we use the packet sniffer, or we call the port mirroring, right? So these are the network security services. And after all, if your organization is suppose very big organization, then how that organization will try to transfer, the exchange the what you call the kind of the traffic from one branch office to another branch office. So for that, another different additional services are also used in this AAA one. For his authentication, authorization, accounting is one. At the same time, at network level, whether you are using the terminal, suppose terminal means in our network side you are using the terminal access control, means ports. You are using the terminal, the access control is also very important by following this authentication, authorization, and accounting. And it will also terminal access control as well as your access control system, called access control system. And another service is we call the remote authentication. Remote authentication by using the dial-in the user, we call dial-in the user service. So these are two different services which are related to your authentication, authorization. So what is the difference between these two? We'll try to check it out. This, yeah. So the functionalities of your the terminal access control and your the radius one is, these are two different services. One is, the difference between these two is in terms of functionality. Your the TACAX, it separates the authentication, authorization, and your accounting as separate according to its architecture. So that means what? Every user has to go through the identity verification first. That is authentication. Then they are allowed what privileges are given, what type of service or set of services are allowed to access the resources. Then their accounting. Whereas your radius is using that it combines this authentication and authorization as a single service. Okay? That means here the packet size is reducing. The number of packets for different services is reducing. So based on that, you can assume that here more number of packets are exchanging, here less number of packets are exchanging by this radius. Means what? It is using the TCP connection. TAC use the TCP connection. That means there is a 3 handshake process. Correct? In pre-handshake process, you are sending a username. Then the server will check whether that username is there or not in the database. If username is there, then the server will acknowledge you enter the password. Then when you enter the password, that password will check in the field of that username row. If it is matching, then it will give the response that now you are allowed to get into the access. So three handshake process. Whereas your UDP is a unidirectional process it is. As we discussed about these services, TCP and your UDP, TCP is a reliable service, whereas your UDP is unidirectional one. UDP means there is no connection, the prior connection establishment between your client and server. When client is ready to transfer the data, simply inject the packets into the network. Now the packets will go through the different route and reach to your destination, that is your server side. Then server side reassemble all those packets to generate a message whether it gives the meaningful or not. If any packets or losing is there, there is a possibility of asking the client to retransmit the same packet or retransmit the entire message. Okay, that depends. So there is no, it is a unidirectional one. So the protocol which is using by this Chaco is the challenge and response part. This challenge authentication protocol. Okay. And in terms of confidentiality, to maintain the confidentiality, the entire packet is encrypted. Entire packet is encrypted means username and password. The entire packet is encrypted. Whereas in Radius, only the password is encrypted. Username is just, it is a plain text only. And whereas the customization part, that means your authorization part, in the authorization of your router commands either per user or per group. That means, for example, if you take the example of our class, then the authorization is given to all the network and system security students, the group of students. Correct? Whereas for independent study, suppose, then there is authorization given to only a person to person. Correct? So whereas in this, the Radius, there is no option to authorize the routers on the one-to-one or one-to-many. Whereas accounting is limited here. Here it is the extension one, the accounting package. So then finally comes to the network service part, your VPN, the virtual private networks. So by following all these security services, any big organization, suppose, they try to establish a virtual private network. So in this virtual private network is created over the public network, over the internet. We talk about this more in detail in the upcoming lecture series. But it typically looks like there is a central site. From that central site, all the traffic will go through the tunnel. That tunnel is a logical connection between your main office and the branch offices. We call the tunneling one. So once that virtual connection is established through your public network, that virtual connection is not allowing traffic from any other network users. Only that group users can use that tunnel. So whatever this tunnel is there, through that tunnel, that group of information, only that branch information will go through that tunnel. Okay. So this VPN uses this virtual connection route through the internet of your organization, of your remote site. So in that, whatever traffic is going on from this branch office to this network, so that this tunnel is not shared by this branch users. This tunnel is not shared by this branch users. When all these tunnels are connecting at the edge router, suppose it, of this network, there all these traffic which is coming from your branch office, mobile users, and your small office or home office will be, the combined here and go to your main office. So because of this virtual connection, direct connection between, that means these users feels that they are directly connected to main office, but actually they are connecting through the public network. So because of this VPN, the confidentiality achieved by encrypting the traffic within the virtual private network. So encrypting the traffic means what here? Sender side, the traffic will be encrypted. Receiver side, the traffic will be decrypted. So here the concept comes, encryption and decryption is there means what? They are sharing the keys. They are sharing the keys. So they are sharing the keys means only users, those who knows that key, are able to connect this network, correct? If they don't know the key, they are unable to connect this. Right? So there you find either they are using the symmetric key or asymmetric key. We'll try to discuss those details when we elaborate this topic more, how to configure and what different services it provides, the IP security services. Okay, so these are the few network what you call the services which are very the important part for your network infrastructure. So in this case, let me ask you now, can you please list out what are the network services are important in the network infrastructure? What is the first service, second service, or group of service? You can tell me. So far, whatever we discussed today, just recall those. Can you list out? Yeah.
The AAA and
NTP, yeah. Purpose? Why NTP?
It has to do with the network time protocol and how everything should be configured to the same time.
That's good, okay. Any others? We spend almost 3 hours time for this because this is very, very important for any of the network administrator, this topic. That's why we spend more time on this to get a detailed description. First one is your access control list. Let me just summarize you again. The access control list. One. So what the access control list is doing? There are two types of access control list which we discussed. There are many types out there. One, standard, good. Another one is extended one. So how to identify it is a standard IP access control list and this is a extended IP access control list means based on number. If any ACL number is there in between, suppose 1 to 99. In the last class we have given the demonstration on ACL and packet tracer. Then you find 10 allow, 20 deny. Those numbers are there. Numbers and the group will be there. So anything from your 0 to 1 to your 99, that is your standard. If anything from your 100 to your 199 is extended services. In the extended services, the access control list try to examine more fields. like source IP address, destination IP address, source port number, destination port number, and the type of services, whether it is a TCP or UDP service. Okay. Whereas in standard one, it won't check all those fields. Only it checks whether the traffic is allowed or denied based on IP address. And the second we have seen the services is your the SNMP, Simple Network Management Protocol. So why we use this means this SNMP it is checking what type of traffic is going inside the network and going outside the network. For managing that, one is network and security monitoring purpose. We're having. So that is very important part. And the next service which we have discussed is your network, the flow security service, and we have seen the fourth one is your port mirroring. That is our packet sniffing, we called it. And your fifth service, which we have seen, your Syslog. So that maintains at what time the users are logged, all the system logging information. That is the Syslog protocol. And the sixth one that we use the synchronization of your entire devices, the network infrastructure devices, that is your NTP configuration. And the system for providing security services like for end users following the authentication, authorization, and accounting. There are two types of there. One is your terminal control access and access control system. That is one. Another one is your the radius one. That is remote access by using a dial-in user, right? And finally, we have seen the eighth service is your virtual private networks. So these are your security services. Okay. Yeah. So that's all in the security services. If you have any questions, you may ask me.